In this video, I've pulled it from the discussion board, and we're going to talk about how to calculate this probability. The probability that x is less than 0.2 and y is less than 0.2, and we've been given the joint probability distribution function. Okay, so we've been given the joint probability distribution function. That's good because this probability is going to be something that we're gonna need the joint probability distribution function for. Actually, I want to rewrite this. I prefer fractions to decimals. So this is the same thing as saying the probability x is less than 1/5 and y is less than 1/5. Okay, that's the same thing. Okay. All right. In general, by definition, since this is a probability that involves x and y, this is going to be, we're going to integrate the joint probability distribution function. Okay. So if it was a probability that involved only x, then we would be integrating the marginal distribution of x. If it was a probability that involved only y, then we would be integrating the marginal distribution of y. If it was a probability that x is less than 1/5 given y is equal to 1/5 or something like that, then we would be using the conditional distribution function. Okay, so depending on what you're trying to calculate for probability tells you which distribution you should be integrating. Okay, all right, so since this is something involving both x and y, we should be integrating the joint distribution of x and y. Okay, so let me go ahead and finish my thought here. So I'm integrating, it says x is less than 1/5. So my integral for 1/5, I should be integrating from my integral for x is -infinity to 1/5. And then for y is less than 1/5, so this would be -infinity to 1/5. Okay. You also might see this probability written like this, with just a comma. All right. That comma is basically, it also just means and. Okay. It's a lazy way a person's writing the union or the intersection. I guess the intersection was too difficult, so they just write that comma. Okay. So, but these are the same thing. And it's different than if there was a bar, right? If there was a bar, then it would be a conditional probability, and we would need the conditional distribution function, not a bar. Okay? All right. So, this is what we need to do. All right, so let us start by graphing our support, so that way we can figure out where is this joint probability distribution function, where is it 0, okay? Because it's 0 a lot of the time. It's only non-zero when this support is true. Okay, so let's graph our support first. Okay, so what I've done here, this is just by definition. It's nothing really to do with this problem in particular. Now what I'm about to do has to do with this problem in particular. All right, so I have y here, I have x here. Okay, let's graph the y equals x line. We have the equal to, so I can do this as a solid line. Okay, here's 1. Here's 1. So this is x equals y. That's that line there. Okay, x should be less than y. So that means it should be less than whatever the value of y is. This is, remember, x moves in this direction, so less would be over here. Okay, and I have the equal, so I have all these are solid lines. All right. So I have this triangle here. Okay, so my function f takes non-zero values when x and y are in this area. Okay, so right now what am I doing? I'm going to be integrating from x's -infinity to 1/5. So where's 1/5 actually? Let me draw this. 1/5. There's 1/5. So from -infinity all the way till I get to 1/5. And y also, oops, that's a little too high for 1/5. Y also goes from -infinity until I get to 1/5. Okay, so if I were to just do 0, a lot of students will they'll say, okay, x is from 0 to 1/5, y is from 0 to 1/5. The problem is that creates this square here. You see the square? That's not what we want, really. We want this triangle. All right? Right here in this red area, this is where f takes non-zero values, and where x and y are both less than 1/5. Okay? So this is where I want to be integrating over. Everywhere else it's 0, so its integral of 0 is 0. Okay? So let's think about that. How are we going to do this integral? Okay, let me go ahead and write this. So the probability x is less than 1/5, y is less than 1/5. All right. So I want to do where it's non-zero, so where it takes this 3x squared y squared. X squared y squared dx dy. Okay, since I did dx first, we're going to want to integrate over x first. Okay, so where x moves in this direction. So if I'm in this triangle, that means x is going from, you see my little purple lines? X is going from 0 all the way till we get to this line here. What's that line? That line is where x equals y. So if I'm integrating over x, so this would be x equals 0 to x equals y. Okay? All right, so now that's already restricted me to this little triangle. So now I can go ahead and take y all the way from 0, here's 0, to 1/5. Okay, so y equals 0 to 1/5. All right? So now my bounds are just this little area. Okay? So let's go ahead and do this integration, and then we'll be there. We'll be done. So let's go ahead. First thing I'm going to do is integrate with regards to x. Okay? So this becomes x to the third power y squared. Okay, so basically the 3/3 cancels. Evaluated from x equals 0 to x equals y dy. All right. So this then becomes y to the 5th power minus 0. So I'm not going to write that. Okay, now I need to integrate with regards to y. 1/6 y to the 6th power, evaluate it from 0 to 1/5. Okay. And I'll get 1/6 times 1/5 to the 6th power. What's 5 to the 6th power? Okay. 5 to the 6th power would be 1/6 times 15625. Right, that's 5 to the 6th power. 1 to the 6th power is just 1, so that's that. Okay, multiply that by 6 to get my answer. And I get 1/93570. Okay. So the probability that both x and y are less than 1/5 or 0.2 in this probability distribution function is really small, right? But it's still a number between 0 and 1. Remember, your answer for a probability should always be a number between 0 and 1. If you get something not between 0 and 1, then you know you made a mistake, because all probabilities are between 0 and 1.